Okay, so everybody's got their little half slip. And again, for some of you, I can't remember, some of you came in late because of whatever. So you can use this on the quiz, just no other notes written on it, right? Okay, that was the thing. That was the thing I did say, you know. So I'll let you in. It's just because I'm not going to be here. Otherwise, I would just project it up here. But so I told Mrs. Payne, you know, so she kind of snooping around at your desk during the quiz to see if you have stuff written down. Because I told her that's what I told you guys. Okay, so anyway, so you could use this. And again, I'm not sure you need it. Really, once you get the hang of it, and you know that this A is always across from that angle, and that's the other sides. And then the same thing here. If you're finding angle A, then it's the other two sides that are plus, and then the A is the minus, and then it's the first two, the B and the C, that are down below, down here. So it's you know, the pattern is pretty easy to see, but just in case, you know, I don't want you to miss a bunch of problems on there just because you have the formula wrong. So, all right, so there's that. And then here's the strategies. Let's talk about the strategies just a little bit. So on the quiz, it's not going to specifically say use law of sines, use law of cosines, right? So I know I threw a lot at you yesterday, so let's try to organize that, our thoughts on that a little bit. So if you have two angles, right, it's always law of sines. Angle, side, angle, 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 side. I mean, that's law of sines for sure, because you can find the third angle just by subtracting the two you know from 180, and then you just set up, because to use law of sines, you need to know an angle and the side across from it. You need to know an angle and the side across from it. Well, in side, angle, side, you don't know the one across from it. So you couldn't use law of sines if you wanted to, right? So it's not even like you have to really remember it. It's just if you have an angle and the side across, you can use law of sines. Now, the problem one is when you have SSA, right? That's when you do have two sides and an angle, and that angle, so you do know a side across from the angle. But it's that ambiguous case. It's that one where there's a swinger in there, and it might not make a triangle at all, and it might make two triangles. So you have to consider that, okay? So then the second strategy we said, if you know all three sides, if you know side, 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 use law of cosines to find the biggest angle. Now, why did we say that? Why would you use law of cosines to find the biggest angle first? So you know if you have two. Because when you have to do an inverse cosine, right, because you'd be using this, you'd be using one of these over here. So if you know the three sides, you'd be using one of these over here. You're going to have to do an inverse cosine. Well, that will always give you either a quadrant 1 or a quadrant 2 angle. If it's negative and you're doing the inverse cosine, it'll give you a quadrant 2 angle, it'll be obtuse. And you know you only have one obtuse angle in a triangle. If it gives you a acute answer, a quadrant 1 angle, and that's your biggest angle, then you know there's not going to be a second triangle. I mean, there can't be a second triangle. You know you've got the right one because that's your biggest one, right? But here's the thing. I might ask you, just because of time, I might ask you some problems where I give you the information and I only ask, so like I could give you three sides and just say find angle A, right? Instead of finding all of them. Just to save some time, just to go through and do it and just find angle A. Well, what if angle A is not the biggest one? Right? So what if I give you side, side, side and say find angle A, but angle A is not the biggest one, and you're like, well, the strategy says to find the biggest one. Does it matter? Why not? Law of cosines will never fail you. Law of cosines will never fail you, right? We talked about law of sines, we do inverse sine. Remember we did the one yesterday, it gave you an acute, but it was supposed to be the obtuse one because there was another possibility. Law of cosines you'll never go wrong. The reason we do law of cosines to find the biggest one is if we're having to find all of them, we might as well start with the biggest one because that one is going to, then we'll know for sure, you know, if there was an obtuse one, it would find it. But my little note down here in red, right? If you start out with the law of cosines, if you want to just keep using law of cosines until you find all the information you need, that's a way to go. I mean, so if you're little, if you're a little unsure, biggest, smallest, all that stuff, that's still not quite, making sense to you, then you can use law of cosines for every one of them, right? Now, probably not all three, but for two angles, and then subtract from 180 to find the other one. And that will never fail you. So law of cosines will never fail you from that standpoint. So that was why we said find the biggest, because then if you found the biggest, then you can feel safe in using law of sines to help to get the rest. Because law of sines is what? Why would you want law of sines? What's the advantage of law of sines? It's quicker. It's quicker. Boom, boom, set up, cross multiply, right? It's a little quicker. But, who cares? I mean, I don't know. But that's why. That would be why you would use that strategy. If you use law of cosines, find the biggest one first, then you can feel safe using law of sines for the rest of it, and you'll be okay. All right? And if it's side angle side, you really have no choice. You find that side that's across. And then, again, now you've got all three sides, right? Now you got all three sides, so now you're kind of in the position you were up here, right? You could use law of cosines to find the biggest one left, or use law of sines to find the smallest one, and then you should be okay. But again, if you just use law of cosines, I said use law of cosines to find the biggest just to keep it consistent with what we did here. But to be honest, you can use law of cosines to find either one. You should be fine. Law of cosines is not going to fail. Okay? All right. So, questions on the homework? 42. Okay? 42. The picture. And that we're going to spend some time on story problems again today. 42. Plane flies 810 miles from Franklin to Centerville with a bearing of 75. Okay, so Franklin to Centerville with a bearing of 75. So that's going to actually be going up. Now, remember, if it doesn't give the north 75 east or whatever, where do we measure from on bearing? Maybe that's a question, so you couldn't even do anything. Straight, it goes up to north, right? It goes from north. So if it just says a bearing of 75 or a bearing of 230 or a bearing of 148, whatever, because bearing, it can go all the way around to 360. So that's measured from north. So if we start here, what was it, Franklin it said? So 75 means it's going to take off like that. It's going to be at a bearing of 75. It's measured from north. Okay, so if it doesn't give those directions, like north, 75, east, or whatever, then it's just that direction. All right, and then it's going to go 810 miles to Centerville. Then it's going to fly from Centerville to Rosemont with a bearing of 32. Okay, so it's going to go out here to, what was that, Centerville? And then it's going to go, so again, I'm going to draw another vertical in here, and now it's going to have a bearing of 32. Okay. So that's going to be 32, right, going that way. Okay, and that was, what was that? Rosemont or something. And that was a distance of 648. So this is 810, and this is 648. And so that's going to create a triangle right there. Kind of a skinny thing. Okay, all right, so we've got side, so it'd be nice to get this angle. We know this little piece of it is 32. We need to know this piece of it here. Okay, well, that's where our horizontal and vertical lines that we can draw in here are going to come into play. I would say I would probably go with something like right here, because this is going to be 90 right there. And then what about this little piece right here? How can I get that? This? Why? Because if we come down here like this, right? This, now my arrow didn't quite go all the way. That right there. So if I got this and this right here, this is 75 down to there. That leaves me 15 right to there. And isn't that going to be alternate interior with that one right there? So I got 15, 75 was to there, 15 to there, and then those are parallel. So 15 and 15. So now we got 32, 15. So if I want to redraw that maybe a little better, something like this. This is going to be 32, 90, and 15, which is what, 137. And then this is 648, and this is 810. Okay? And so, and then I assume they wanted straight line distance from Franklin to Rosemont, which is this line right here. Right? So x squared, or whatever you want to call it, would be 810 squared plus 648 squared minus 2 times 810 times 648 times cosine of 137. Now, on the, and you can do square root of that. On the quiz, it's going to say, show your work. By show your work, I basically mean the problem set. Okay, now I know many of you, if you just had this picture in front of you, right, you already know this, so you can just start typing. I want you to write it down. Okay, because then I can see where you're making mistakes. If you make a mistake, right, well, it's two reasons. Partly because I won't be here. Because if you just have an answer, then, you know, probably means Seth was looking on Claire's paper because he didn't know what to do. Right? He was really, oh, he's not here. Okay. You know what I mean? So, I mean, that's part of it. You just write down an answer. Where did that come from? I have no idea. Right? And then, but also partial credit, right? If you type something in wrong, you know, and you get the wrong answer, if you've got it written out and it was right, exactly right, and then you had it wrong, I mean, you're going to get more partial credit probably too. So at least the initial setup. Same thing with law signs. Okay. Now, once and on a story problem, we only need this one thing, right? They only in this story problem. Some story problems ask for a couple different answers. So be sure to read carefully what it asks for, and then make sure you square root this. And so, what was the final answer here? 1,357.85. Okay, let's round that to 9. Let's just say right now, I think I'll probably leave a note for the sub. I didn't put those directions on the quiz. Let's do everything to 1 decimal place. Let's do everything to a 10th. Okay, so 1,357.9. Now, if you do more, I'd be okay with that. If you do 8.5, which would round to 9, I'll be okay with that. Less is no good, right? But I mean, just to make it easy, let's just do 1 decimal place everything. Now, keep in mind that the distances, the sides of the triangles, it's way more important to keep those numbers accurate as you go throughout the problem, okay? Because you end up squaring and stuff like that. With the angles, you're just doing the cosine and the sine. You do the sine of 137 or the cosine of 137 versus the cosine of 137.1, there's not that much difference when you do the sine and the cosine of those. And so in the calculations, those don't make a huge difference. But if you have a distance of 6.4 and it's 6.443 and you just round that to 6.4, when you square that and subtract and do other things to it, that throws it off. I mean, that could throw it off quite a bit, you know. And so that's where if you're going to be using a side and squaring it, putting it into the log cosines, whatever, make sure you carry out some of those decimals. Jot it down on your paper, store it in the memory of the calculator, whatever, so that you don't get thrown off by that. Okay, that's going to cost you a ton of points if you're off because of that rounding, but it may cost you more. Yeah.
So yesterday there was this problem. I had to save 2 answers that went out. Too many decimal points to even have on this.
Right.
And so I wrote it all the way out that I could. I used that to divide by, and I still off by 0.03.
From the answer book?
Yeah.
Yeah, I'm not so sure. Sometimes in the answer book they don't use rounded values, which they should. But I don't know. I'd have to see the exact one, you know. But I would think to 1 decimal place you should be okay. And I'm going to work them out on the answer key. So you know, okay, if you round, what, you know, did you do this, whatever. I'm okay if you write down on your paper, like when you're doing the calculation. So let's say you had done log cosines right now, and we got 1,357.9, but it was really 8.5 something, right? You guys were saying. It's really 857. So now, let's say you are now going to want to find this angle here, right? I mean, let's call that angle A. I don't know. So now you wrote down on your paper cosine A equals, and then you would use 810 squared plus, and then you'd want to write this down. I'm okay if you just write 1357.9 squared, but when you actually type it in, you should type in 1357.8 squared. You see what I mean? So when you write it, it's okay, but when you type it, and so what I'll do a lot of times when I write it down is I'll go 8 ... just to remind myself that there's more there. Is that what you said?
It's 847. So when you round it,
so it should have been, what, this was 847?
yeah.
So it should have just went 8. Oh, I got you. Okay. So, oh yeah, because you said 8.5, right? So, but you see what I mean? So when you're showing your work, you don't have to write out 6 of them, right? You can, but when you go to type it in, you should. All right? Because that, like I said, that makes it. Okay, so getting them set up, that's our part of story problem. We're not going to do as many story problems on this quiz. When we come back from spring break, probably spend at least one day kind of reviewing it, probably a little bit new. We're not doing a whole bunch more in chapter 6, actually. So probably when we come back from spring break, we'll probably have at least a review day in there, or part of a day of review, and a little bit of new, and some review, and another a little bit more new, and then review it all again, and then we'll just take a test, another kind of quiz test, very similar length, maybe a little longer. That one may have more story from it, so we may come back and do a few more on that one. But so this one's going to have a few, 3 maybe, on it, and then some other ones where we solve. So I'm sure we'll have some where you have to solve the whole triangle. But if it says solve the triangle, that means find all the missing parts, right? There might be 2, might be 1, might be none. Probably be some problems where it says how many solutions are there. That's all you have to do. And I still may say show your work. So depending how you do it, if you do the B sine A thing with the height, right? And we can talk about that here a little bit if you want to. Well, I have one of those, I think, where we're going to say how many solutions are there. So if you do that, just write down what it is you're typing in calculator. If you're going to just start working it and see if you get an error or that kind of thing to determine how many there are, then that's fine too. Okay, but just write down what it is you're typing in your calculator. So. All right, so let's do that. I got one right here. Okay, so how many solutions? 0, 1, or 2? 0, 1, or 2.
Let's just find how many.
Just how many. Don't solve it, just how many. We'll do another one here in a minute where we solve it. All right, what do we got? How many? $120.
It's frozen.
Oh. So remember we said always draw that. It is 120. It's not important that you draw that as an obtuse, but it may help. The 6 would go here. The 9 would go here. Okay, so now it is obtuse, which tells you what? Well, no, it doesn't tell you there's only one. It tells you that there can't be 2, right? There can't be 2. So if you got 120, so if you have an obtuse in there can't be 2, okay? But there could be 1 or none, right? And it depends whether what? What's it depend on? Yeah, it depends if this is long enough, right? But if this was more, what if this was more than 9? Then it's long enough, and so there's how many? There's 1, for sure. There's 1, okay? If it's shorter than this, then it's like, okay, there could there be 1 at all? Can there be 1? Oh, if it's shorter, on this one, if it's shorter, there can't even be 1, can there? Because there's no way. I mean, it would actually come down, and now my picture looks like, but there's no way it can be that long, right? If it's 6, this is 9, there's no way that is. So if it's 6, it's only going to be there. So we really don't have to do anything. Because remember, the B sine A is only necessary this is acute, right? We don't have to worry about the height, because the height, there's not even a height in it. Okay, so now let's change that. Let's just change that to 60. Okay, let's change that to 60. So what if that would have been 60, and this would have been 9, and this would have been 6? Okay? Now what we would check? Now we would do the B sine A thing, right? If this would have been longer than 9, you know there's only one, right? If this side's longer than that, you know there's only one, because there'll be one over here. When it swings around, it's not going to fit. But the B sine A, the 9 times sine of 60, what is 9 times sine of 60?
7.79.
7.79. What's that tell you? It tells you that's 7.79 right there. So what's that mean? There's none. Okay? What if this would have been 8? Now there's 2. Now there's 2. This is 8, so this is 7.79, so 8 would be here, and if you swing it around, there'd be another one over here. There'd be another one over here that would be 8. So there'd be 2 of them. Okay, so that's kind of how we did that. All right, let's go ahead and what about solving if there's 2? Do you want to do that? If there's 2, because that could happen tomorrow. Because I got some law cosine ones we want to practice. There are some other law sine worksheet we'll do after lunch. But, okay, let's just look at this real quick. So let's go ahead and start setting this one up. And let's talk about, we don't have to finish it all the way out, but let's talk about this one. So, again, the directions would just be solve the triangle. It's not going to say on there use law sines, use law cosines. Just it's going to be solve it. So you're going to draw it. You're going to decide what you need. Go from there. How many triangles are there? There are 2, right? Either do the B sine A, the height thing, or just start working it and assume that there's going to be 2. Either way. Okay, so what do you get for What's the first thing you find? Angle C. What'd you get for angle C? 27.1. Okay, so if you round that to 1 decimal place, 27.1. Right? 27.1. Now, maybe you decided there were 2 right away, or once you find that that one is 27.1, know that since sine, you did inverse sine to get that, there could be another one in quadrant 2, and so you do 180 minus 27.1, right? And that's 150, 150 what? Had you gotten that far yet? 152.9. Okay, so let's just talk about this. This is as far as I want to go with this right now. So again, if we're doing the thing with the height, okay, when we draw it, we want to put our angle down in the bottom left corner. Okay, we got 30 over here, we got 40 here, right? So 40 times sine 20 is 13.6. So if this side was bigger than this side, we'd have 1 for sure, right? Only 1. If it's littler, the question is it too little? Right? Is it too little? Well, we do the height right here, we get 13.6. So right down here is 13.6. So this is big enough, right? If it was less than that, it'd be no triangle. So it's going to be 1 here, there's going to be 1 over here, right? So we do our thing, right? Set it up, get 27.1. But you know there's going to be another one. Now, if you hadn't done the height thing, you just assume there's going to be another one. Here's what would happen, right? What happens if you don't do this height thing and you set this up anyway? And what would happen if there's no triangles? What would happen here? You get an error on your calculator, right? You go inverse sine, you get an error. Okay, no triangle. If you work it and you don't get an error, you get 27.1, just assume there's going to be another one. Because this is an SSA, right? This is an SSA, so that's why we're thinking it. Okay, so you assume there's going to be another one. Now, what's going to happen if there actually isn't a second triangle? Well, what's going to happen is this is going to be too big. You'd get something like 170 here. Right? You get like 170 for your second triangle. And you go in and try to put 170, what happens? 170 and 20 is too much, right? That's 190. That's too much for a triangle. So you know this one is no good. But this one is okay. 152.9, if you put that in there, plus a 20, that's 172.9. So that's how you could know without doing the thing with the height. But if you did the height, you know there's going to be 2. There it is. And so then that leaves you 7.1 for the other angle A, or in this one, right, that's 180 minus 20 minus 27.1, you get 132.9. So everything left now is to find little a. So you got 2 calculations to do. Find little a using, now that you know that angle A, or then find little a using this angle A, right? So that's all you have left to do is find little a. And you got to do 2 calculations. One of them will use that angle, one of them will use that angle. Okay? All right. And I would probably, like I said, I would do sine 20. I would do sine 20 over 30 and sine 132.9. So here it's probably okay to use the rounded. We said that would get you the little a for over here. And then sine 20 over 30 equals sine, 7.1 over little a. And that would get you the little a for right there. Right? Yes.
So our homework on 27, it was 1 triangle,
right?
But I got the reference angle and I got the opposite.
Okay, let's look at that.
Like, how are you supposed to know which one to?
Tell me what you were given on 27.
Pull out the equation.
I got it. So you got A equals 8, C equals 5, and B equals 40. That one? Okay, so here's B, 40, that's triangle. So it doesn't matter where A and C are. So A would be 8, C would be 5. So side angle sides, we're doing log cosines, right? So you did, this is B. So you did B squared equals 5 squared. This is what the equation you're saying?
Yeah.
Minus 2 times 5 times 8 times cosine of 40. And what did you get for B? 5.26, something. Now what'd you do from there?
Well then you just use that.
Right.
Sine of 40 over.
So now you went with law of sines, good. Sine of 40 over 5.26, something, equals?
Well, the answers in the books, A was 102.14, so then originally I got the opposite of that, the reference.
But tell me what you did. Tell me, do you see it
Sine
work?
40 over 5.26 equals sine of A over
What did you do wrong? What strategy did he not follow? You're going to use law of sines after doing law of cosines. Use law of sines to find the smallest. And you did law of sines to find the big one because across from 8, 5 is littler than 8. So you should have done it with C, and then you wouldn't have went wrong. That's the problem. Law of sines, anytime you have to do an inverse sine, it's going to give you a acute angle. But it might have supposed to have been an obtuse. Law of cosines will never give you that problem. So you could have done law of cosines to find angle A, and you'd have been fine. Or use law of sines to do the little one. See, because here's the thing. So that's 5.26. You got 3 sides. This is the biggest of the sides, right? So right here, I can tell, before you even set up your law of sines, I can tell that this angle has to be my biggest one. If you use law of sines to get that, it's always going to give you an acute, and it might have been obtuse. Now, it might be acute, so you might get lucky. So that's where you're going. So your question was, how would you know? You wouldn't. You wouldn't, right? Because you could do law of sines to find it. It'll give you an acute. And then what would you do? You take these two, add them up, subtract from 180. You get that. You think you're fine. And you would, well, and here's what would happen, though. This would probably end up being your biggest one, and it's not across the biggest side. So that maybe is how you would know. Do you think it's the rounding thing? Like, did you carry out 5 or 6 decimal places when you typed them into your calculator? Then I'd say, and I could look. Did you look at in the back of there? Or might double check those. Okay, what else? Okay, all right. What I want to do here before lunch, we don't have a whole lot of time. We'll carry it over in a little bit after lunch. I've got a worksheet here too, but maybe we'll just do like the odds or so on the worksheet because it's not like we need to do a ton. We need to do some, I think, a variety. But maybe we'll just do, because I want to work on some of these story problems. So on page 442, let's work on these. And like I said, let's work on this up through lunch. And then maybe a little bit after lunch, and then I'll give you this a worksheet here too that's got a mixture of law of sines, law of cosines. This is mostly law of cosines. Okay, I think these story problems are. So I want to mix in some other stuff. So you can work together if you want, work along, whatever. Answer books up here. Give me an example there, McKenna, of one of those where that was off a little bit. 27. And you had, give me a number. Angle A at 102.38. Yeah, this says 102.44. It said that same thing. I wonder if they didn't use the rounding. I almost think yours might be better. Hey, did anybody else agree with that on 27 on the homework? Angle A was 102.38, and that was using like unrounded values. They get 102.44, so I think the book is not as good as we are. I think they use rounded values in their answers. No.
Yes.
What?
No.
Oh, the ones on CBS. I think the other.
I got worried. I just got worried. No.
As long as.
Wait, what is the Oklahoma shooting degree?
Oh, here it is.
No, these are highlights.
Oh, those are
What is Oklahoma shooting degree?
a calculator?
Yeah.
Thank you.
These are.
Oh,
I don't know.
Kale.
These have, oh, this one just started. Here we go. The ones on TBS and stuff, I think.
Yeah.
No, that's fine.
Same.
No, I'm not like the answers, it's just like, yeah.
The hard part.
Plus.
Okay.
See, if you choose the crappy books.
No, I
Says frontage like flat.
Say that again?
It says the triangle parcel of land has 115 meters of frontage. We draw them as like a model line. 'Cause it's the biggest one.
Well, yeah, it's just between the two. Rick, which one you on?
Those are smaller.
What angle does the frontage make with the other two boundaries? So it'd be those two. So what angle does the frontage, yeah, so that. Well, no, that's a good question. What angle, yeah, I heard that, figured this out when I was picking some problems for a quiz. Make the question obvious, but it does say angles.
Okay.
So it is plural. Yeah, I didn't, that's what I was checking. So it'd be those two.
Triangle right here is one.
Mr.
180 minus
Yes.
75.
Yes.
So for the,
That's 180.
for a triangle that has the two answers, like the one where you had 137.9,
Right.
but then you get that one, do you just use a reference angle to subtract 180?
Well, yeah, C would be 27.1.
Oh, yeah, sorry. That was just my work.
Yeah, because here's what's happening. Here's what's happening. When you do inverse sum, okay, when you do inverse sum, and you get 27.1, right? The other one is
Okay.
so you have to do 180 minus 27.
What if you if you accidentally use like A and you get the wrong thing, right?
What do you mean if you accidentally?
Like
You had no option.
you did 180 minus.
You couldn't use A. You were locked in. See, if you have side angle, you have to use the 20 and the 30, and then you have to use this angle as across. So you had.
You can't do that.
You can't do that one up there because you got two of them. Sine of A. So, yeah. So well, you have to, right? You have to use those three. So you're gonna do sine of, what was it, 20 over 30? And then you're gonna have sine of C over 40. So you take that times that, and then divide by that, and you get sine C equals some decimal. When you do inverse sine, it's gonna give you this one, but it could be this one over here.
Okay.
Now, the other way of thinking about that is you got your 20 degrees here, right? You got your 30 here, and you got your 40 here, right? So when you get to 27.1, that's that one. But remember, here's your height, was 13 something. When you swing, the swinger, right, that would swing over to here, right? That would also be 30, right? So that's why there's two.
See, that's what I was thinking.
So that's why this one's 27.1.
So that's also.
That means this is also 27.1,
Okay.
right? Because it's an isosceles triangle. And so what's this thing? 180 minus 27.1.
So I had that isosceles triangle on my worksheet. Just
Yeah.
From there, I was having trouble
Right,
figuring out. So
and since it's
just basically
isosceles, those two are 27.1, when you swing that over there.
So I'm 180 minus.
So that's 180 minus, so you can think of it as a reference angle, or you can think of it as just 180.
Okay.
Okay.
Thank you.
Thank you.
The largest angle is always the one across from the largest side.
That's right, largest angles across the largest side.
Watch, there's like a million upsets.
Tennessee loses right away.
And I don't have that.
I got it.
Oh, stop.
So
So which part?
There's a really good signal.
Oh, it's good. Right there, you don't see it. It's angle B. When the B is here, it's B is here. Right?
Oh, I was looking at C squared, that's where I.
B squared equals MC. Yeah, this letter here, this side here always matches with that angle. It's always a cross. Yeah. So the, yeah.
Would you put it in your calculator?
Well, that is
Just
a
get
good
parts too.
question. I'm gonna have some, there'll be somewhere I set them up for you, and there'll be somewhere
Rebecca, could you go?
you have to sit. Is this 44? And this one's very, very simple, but it says a triangular parcel has 150 feet of frontage. That means that means this, okay? And the other boundaries have only 76 and 2, so that'd be easy. What angles does the frontage make with the other two boundaries? So they'd be asking the question.
Yeah.
It's 52.8.
So, yeah.
That's the.
Maybe I can.
Almost be taken.
Walk.
41.2.
How would you do that? How do you only answer the, like, both of your angles?
I rounded up.
Oh, okay.